important insight. A pattern-like command is not a UI pattern, is not a database pattern, is not SQL. It is behavior organization pattern. So this is the behavior you would describe in your source file that will then be converted into a stock and to a heap, and then again heap is a region in memory that will be executed in bytes and then be fetched by your OS to your CPU. It answers who is responsible for executing an action, not how do we render, how do we store data. So it is the one responsible for executing an action. Like you're encapsulating an action into a source file so that you can control its behavior at runtime to whichever object you planned it to be executed at runtime. 8. Clean mental model. Think of it like this: UI layer to application layer, commands live here, to the main layer, business rules. This is where your backend lies. So the UI layer first before the commands and then before the backend. And then the infrastructure layers such as DB, PostgreSQL APIs or third-party APIs you import on your app. Now patterns like command live mostly in application layer, sometimes the main layer. So again, it could be blended, but just like how the compiler and interpreter could be the same compiler and interpreter at the same time, just like with Go. Go provide an interpreter that evaluates the source code and run it immediately, but also provide a way to compile it, and then have others know nothing about your compiled executables. They just execute that into your machine, and they don't have, or you don't need to be aware of who actually implemented. So that's how abstraction works. Just like with philosophy of software design, and just like with GPU. So the GPU are actually executing what Material UI library, which is a React code or function component that actually help you style your browser display. So the GPU is not aware of that. It's the browser rendering engine that actually provides the CSS or the graphics command in order to change the style of your browser or display. Final answer to your question: yes, those patterns are mostly describing backend logic structure, controller or service logic, domain behavior modeling. They are not yet describing UI presentation, SQL implementation details. That comes in architectural patterns like MVC, MVP, MVVM, clean architecture, hexagonal architecture. React.js design patterns. An introduction to React. When front-end developers talk about code, it's most often in the context of designing interfaces for the web. And the way we think of interface composition is in elements like buttons, list, navigation, etc. So the drop-down list, the navigation, such as a browser links page, such as home or product slash tires slash the specific tire brand and the specific tire within that tire brand. So those are just an element. So that's how we think about that in code or interfaces in the web. Now React provides an optimized and simplified way of expressing interfaces in these elements. So the reason for that is because it does the declarative instead of the previous way of imperative programming or combining HTML, CSS, and JavaScript. It also helps build complex and tricky interfaces by organizing your interface into three key concepts: components, that's the functional component we discussed, props, and the state. So these are the three basic components of React. Because React is composition focused, it can perfectly map to the elements of your design system. So because it is not an inheritance, so it's composition over inheritance, it can map to the elements of what we used daily in the browser, such as navigation, buttons. So designing for React rewards you for thinking in a modular way. It allows you to develop individual components before putting together a page or view so that you fully understand each component's scope and purpose. So this is where the functional component builds the page on your browser and builds the view so that each functional component are in controlled scope, so you control exactly the object declaration in memory or what data structure will eventually run in runtime, a process referred to as componentization. First terminology used: React DOM. The React DOM package providing DOM specific methods for client and server rendering. So if you want to render something in the front end or in the client, you would use a DOM, a React DOM package, which is a library to contact the DOM API of the browser. And if you want a server rendering to be able to connect not just in the front end but as well with your back end, maybe you're using some back end, you're just responsible for the front end, then you will use the server rendering of this DOM package. JSX, syntax extension to JavaScript. Redux, centralized state container. So it goes back to the three concepts, which is state, props, and components. Hooks, a new way to use state and other React features without writing a class. So again, hooks help us convert the class component into a functional component, but at the same time, it also goes back to the three key concept, which is component, props, and state, because it's a new way to use the state. So remember the hooks. We will discuss that further in moving forward. React Native, the library to develop cross-platform native apps with JavaScript, such as in mobile phone. Webpack, JavaScript module bundler, popular in React community. So you might think that Webpack only eliminates the dead module in JavaScript, but it also does that in React. Single page application, a web app that loads new content on the same page without a full page refresh or reload. So the SPA is actually what we used, for example, in our app in a Next.js, where we load a lot of pages up front so that a new page or a new click won't need to be reloaded because it's already in the that same page. So like it's SPA or client server rendering. You only need to load one HTML once, and that HTML already provide all the JavaScript it needed to browse or click those elements in the page. But for a page that needs a server rendering, you would need a server rendering for that, such as the data that usually change, such as analytics, because you constantly needs to pull that, or a CMS navigation system, such as an interactive CMS edit blocks. So when for example, we're editing blocks in a page in a CMS. Now, basic concepts: JSX is an extension to JavaScript that embeds template HTML in JS using XML-like syntax. So it actually embeds the JSX embeds the pattern or the syntax of HTML in JS, kind of like an XML-like syntax. So the XML, we discussed this before, and the HTML in the JavaScript, we also discussed that in React. It is meant to be transformed into valid JavaScript, though the semantics of that transformation are implementation specific. So the semantics where the meaning of that transformation are implementation specific. It really depends whether you're using React in Next.js or you're using React as a React only. JSX arose to popularity with the React library but has also seen other implementations. So the one that makes the JSX popular is actually React library. Now, first correction: HTML and CSS are not compiled to JavaScript. You ask, so you mean HTML, CSS, JavaScript are compiled to only JavaScript? No. Browsers run three different engines: language, HTML, engine HTML parser, language CSS engine, CSS engine, language JavaScript engine, JS engine, or the V8. Example browser engines: V8 for the Chrome/Node, SpiderMonkey, Firefox, JavaScript, Core, which is for Safari. And again, these are run in C++ engine. HTML and CSS are not compiled into JavaScript. Instead, HTML to DOM3, CSS to CSOM, JS to modifies DOM. React uses JavaScript to generate DOM nodes. So again, it uses the JavaScript to generate the DOM nodes or the nodes element in the browser. Again, so it's the same here. Correction: are not compiled. You mean browsers have three different engines: Google Chrome, HTML parser, build DOM3, CSS parser, build CSOM3, JavaScript engine runs JavaScript. Now then the browser combines them into the render tree: HTML, DOM3, CSS, CSM3, JS modifies DOM. So HTML is not equal JavaScript, CSS is not equal JavaScript, only TypeScript and JSX compile to JavaScript. Now, second correction: React is not a compiler. React is just a JavaScript library. It does not compile code. Example: React runtime function, React.create element parameter high string, comma null, comma hello string. JSX is what compiles into that. So JSX to JavaScript, React to library used by that JavaScript. So JS turns into this JavaScript, and then the React is the library used by that JavaScript. Second correction: React is not TypeScript. You wrote, I thought React is a front-end and separate and makes writing UI easier than TypeScript. Correct instinct, but slightly misaligned. React and TypeScript solve different layers. Tool: React, purpose UI rendering library. Tool: TypeScript, purpose static type system. Tool: JSX, purpose UI syntax. Tool: TSX, purpose JSX plus TypeScript. So if you want to combine the React, which is the JSX, and the TypeScript, you would do TSX. So in modern apps, they are combined. Third correction: JSX and TypeScript are separate systems. You were confused by this pipeline. Let's fix it precisely. The real pipeline: TSX file to TypeScript parser to AST to type checker to JSX transform to JavaScript output. So the TSX file are really being parsed by a TypeScript parser, not next.js. Doesn't have to do with that. It's just TypeScript. It builds the interpreter AST representation. Then it type check. So after it type check, then it is transformed, to an JSX structure, which is just React. So we have TSX to React. Then React will follow its compilation pipeline, which is just a library turned into a JavaScript, and that JavaScript will then turn into its own compilation pipeline. Important, JSX transform is part of the TypeScript compilation. So your confusion here is valid. Earlier I separated them conceptually, but in practice they happen inside the same compiler system. Example, input TSX, function greeting with a parameter object with a props member and a value object again with a member name and a value string, and then inside return h1 hello, then parameter string interpolation props that name, then closing h1. Now after compilation, it will be turned into a JSX, right? Function greeting parameter props, and then inside React that create element parameter h1 string comma null comma hello string comma props that name. Now types disappear because of the TypeScript type checker after it builds the representation. So again, it does the transpilation, or it is compiled to a JSX and then follow the JSX pipeline. Only JavaScript remains. So let's go back to here. So the actual stock, this is the loop you're trying to close. Modern front-end architecture looks like this. Application code, two React components, which could be a JSX or syntax, or TSX, which again TSX first turn to JSX, then TypeScript type system to check that AST, then JavaScript, then browser runtime. Important idea, TypeScript disappears before runtime, just like your book said. So what TSX actually mean? You ask, what does this mean? Type props equal inside this name value with a value string, then next line function greeting with the parameter object with the small letter props with the values capital letter props, inside return h1 hello with string interpolation parameter props that name closing h1. Now break it apart. TypeScript part, type props equals to member equals to object with a member name with a value string. This only exists during type checking. It ensures this greeting name is equals to string Alice, and then greeting name is equal and it's not greeting name is equals to an object, and then inside that object is a integer 1 2 3. Then function greeting parameter props, small props member, and the value capital props. This says props must follow the props type. So these props must follow this means that props must follow the props type, but in runtime again it is converted to React. Now React part, return h1 hello with parameter string interpolation props that name closing h1. That JSX become React that create element parameter h1 string comma null comma hello string comma props that name. So what the TSX really means? So that TSX implement TypeScript to JSX. Example, types prop equals to inside name member name with a value string, then function greeting props again. So two things happen here. TypeScript part, type props, then props with following the capital props. So this exists only in type checking or in the TypeScript part. They disappear when the JSX is converted. Now JSX part h1 hello parameter string interpolation props that name, then closing h1. This become React that create element parameter h1 string comma null comma hello string props that name. The real compiler pipeline. Your confusion came from missing two compilers. Let's fix that. Step 1, type script compiler using TypeScript. So we have TSX to type checking to remove types. Example, props, small props with a value capital props becomes just props. It's just following that props type. Step 2, JSX transform. Now JSX is transform. H1 hello closing H1 becomes React.create element H1 string comma null comma hello capital hello string. Step 3, bundler. Tools like Vite, Webpack combine all modules into optimized JS. So after JSX, you don't transform it directly into a JavaScript. So you use Vite or Webpack. So Vite is the same as Webpack, in which it also removes dead modules. So it is optimized into it turns into an optimized JS that you can run at runtime. Now final pipeline, the TSX source code to TypeScript checker, to types remove, to JSX, to React.create element, to bundler optimization, which is Vite or Webpack, to JavaScript bundle, to browser. Now the deeper architecture, you said, I thought React is separate from TypeScript. Correct. There are orthogonal technologies. Think of it like this. React is the UI framework, TypeScript static type system. These solve different problems. Problem UI rendering, tool React. Problem type safety, tool TypeScript. Problem syntax for UI trees, tool JSX. They combine nicely. 6. Why union appears in React? This example you posted, type status equal string loading or string error or success. This is used for state modeling. Example UI, loading, which is a spinner, error message. So this error is kind of like the object we have with, for example, creating a language. So this will be the basis or state to control that state, because you don't want them into the same class to avoid dependency, because these states could be happen in different components of the app, such as this error message could be backend loading spinner, could be front end combination with backend, success show data, mostly like backend. So React component, function screen, parameter status with type object status with the type value capital status. Inside this if status equal loading, then return spinner closing, then if status equal error string, then return error message closing, then return content tags. Now TypeScript guarantee every state is handled. This is very powerful UI correctness. So basically TypeScript helps React guarantee that every state is handled, so that you won't mistake in writing the UI in a React JSX. And again, it is transformed from the TSX to JSX. Now, why unions appears in React? This part of your book is actually very important for UI systems. Example, loading success error in TypeScript, type status equal vertical string loading or success string or error. Then React use narrowing, function screen status, no if status, so it's the same thing. TypeScript guarantees status must be one of those states. This prevents UI bugs. So again, TypeScript are now being used to prevent UI bugs. 7. The compiler concept, or TypeScript are being used to check that the JSX to maintain, to make the React more declaratively, because remember, React already abstracted the HTML, CSS, and JavaScript. Now you're making it more concrete. Now the compiler concept you quoted, your book description is correct. Source code to AST, to type checking, to output code to runtime. But JavaScript is unusual. Most languages compile to bytecode. Example, Java, Python, C, but TypeScript compiles to JavaScript, its transpilation. Then JavaScript engines compile again internally. For example, Python TSX to TypeScript compiler to JavaScript to V8 engine to machine code. 7. The biggest misunderstanding you see in your reasoning. You're thinking TypeScript replaces React, but actually, TypeScript equals the safety layer, React equals to UI engine. They complement each other. 8. Subtle misunderstanding that would hurt later. This is the most important correction. You're mixing syntax layers with runtime layers that separate them clearly. Development time tools, TypeScript, JSX, TSX. This exists only while writing code. No runtime tools, JavaScript, React Runtime Browser. It's the same thing with a source file in an interpreter and compiler, where the source text is really the language, and those are being type checked or parsed into an AST node, and then AST node will then be represented by your interpreter. So that will be the basis of your interpreter. So source file doesn't mean anything at that point. And then at runtime, those would be the stack and the heap. So the stack and the heap, that's where JavaScript and then React Runtime and Browser Engine comes. It's the region in memory to how the source file objects are declared at the source file. Of course, that's still connected and then fetch into a CPU. So this exists when the app runs. So the biggest misconception you're close to making, this is most important correction. React is not a UI language. React is state-driven DOM renderer. So again, it goes back to how the React render the same thing when the state doesn't change. And again, hooks replace how React represent the basic components of the React, which is components, prop, and state. So JS is just a syntax for a state-driven DOM renderer. So you're describing the DOM layout. So as DOM renderer, that's also how the DOM API are connected to like client-side rendering and server-side rendering. So React internally builds something called virtual DOM. So you have JSX to React elements to virtual DOM tree. So that React elements functional component really become the virtual DOM tree, which used to be an HTML and JavaScript. Now diff algorithm to check the reference instead of the value, right? So you're referencing something and then rendering the same thing if it doesn't change, and then DOM updates. This is why React is powerful. Now 9, React itself is just functions. React components are simply functions like function greeting, parameter props inside return React that create element parameter h1 string comma hello string. JSX just make it prettier. So 10, your understanding gaps very honestly. Your thinking is already advanced, but I see 3 gaps. Gap 1, mixing compile time tools with runtime systems. So again, compile time tools is where you have converted that into an AS3, the TSX, right, into a JavaScript, into a React and then JavaScript. So you're transpiling it, so that's compile time. That's different from the JavaScript runtime. Kind of like how the internal representation are different from the one or the IR immediate representation of the AST into a runtime, which is the region in memory. So gap 2, not seeing React as just pure functions returning UI objects. Gap 3, not seeing JSX as syntax sugar only. So subtle gaps in your understanding as me identify errors of omission. Here they are. Missing concept 1. You haven't fully internalized DOM versus virtual DOM. This is the heart of React. So there's a DOM, the actual DOM, and the virtual DOM that the tree created by React. Missing 2, you haven't yet studied React reconciliation algorithm. So that reconciliation algorithm are really how those representation of JSX syntax turns into a React that create element, and that React that create element turns to another object structure that then be passed to a JavaScript. Kind of like with how the JavaScript turns into a different representation as well with its primitive values such as string or number, where the string, if you apply a method to it, it will wrap that string into an object so that you can apply the method and then pops out that uh, and then pops out that wrapper that helps you activate that method to that primitive value after you have used it. Kind of like how stock, are being popped. So you pop the first the main class, and then the function inside that class that is being executed, and then after that function or pop, the main will the last to be popped. So it's the same concept with that. Missing concept, this explain why React is efficient. Now missing concept 3, you haven't fully connected state to render, to diff, to update. Now React is basically a state machine for UI, because again state is the basic, which is the related to the props, because state is really the per component value at a specific instance of time. Now it will render it depending if it's the same or not. Using a diffing algorithm, React will compare the tree, the DOM tree. If it's the same, it return just the last reference. And if it's different, therefore it will build another tree and then update the DOM. Now React is basically a state machine for UI. Missing concept for the build toolchain layer, a bundler to transpiler. So a bundler first, it optimizes to JavaScript, and then transpiler to optimizer. Example tools: Vite, Webpack, Babel, TypeScript transpiler optimizer, which is the V8 engine. Now book that matches the quality you want. You specifically ask for books like Learning JavaScript Design, Philosophy of Software Design. Here are the best modern books: Road to React, Clear Mental Model of React, React Internals, React Explained, Focus on Architecture, Front-End System Design, Micro Front-Ends in Action for Large-Scale Front-End Architecture, JavaScript Deep Internals, you don't know JS yet, still the deepest JS mental model block, TypeScript Architecture, Effective TypeScript, Very High-Level TypeScript, Design Knowledge. The final closed loop mental model, everything fits into the stock. Application logic to React components to JS syntax, to TypeScript types to JavaScript runtime to browser engine, compilation pipeline, TSX source, TypeScript compiler, JS output, bundler, browser V8 execute. But again, this TSX TypeScript compiler to JSX for to JS. Then application logic, React components, JSX. If it's TSX, of course, that's a different pipeline. But if you have the JSX in front end and then TypeScript as your backend, this is will be the pipeline. TypeScript types to JavaScript to runtime to browser engine. Now TSX source, TypeScript, JS bundler. So you bundle first the JavaScript into browser and then V8 execute. Final thought. Your question shows your okay. So books that will close the loop based on your level, reading level, Goldberg, Cherney, Adi Osman. React Design Pattern and Best Practices by Michelle. Deep Architecture of React Systems. The Road to React by Robin. Very clear conceptual explanation of React internals. Third, build the front-end web framework from scratch by Carlos. This is extremely powerful. You actually implemented your own React-like system. Designing that intensive application, not React specific, but completes the system design mindset. Final insight, you are asking the exact question people ask when transitioning from. Okay, so eventually, so the key mental model is to remember is TypeScript, is compile time say TJSX to syntax, React to runtime UI engine, browser to execution environment, everything eventually becomes JavaScript executed by the browser. So we'll continue with this.